Not even. Ooh. Agree. I feel like we're going. Take the passport. Okay. The area of the parallelogram is the magnitude of the cross product. So let's try to calculate the cross product and find its magnitude.
It's like starting to.
Yes, 70. Jesus. For you, like 68.
See me? I'm going up. I keep going. I go 79, 85. I'm in the 40. Minus 4 minutes.
Okay, let me see your information on the scanner. You already have the answer. Don't have to report it. Thank you. Yes, that's right. So yesterday we introduced the calculation of cross product. It's useful for calculating a new vector that has depending the relation with two given vectors. So let's review the calculation. Another thing is cross product, its magnitude allows us to calculate area. So what we do is these are actually two vectors. A cross. And find the cross product, it's two vectors. We went to it's two vector. A cross B, A on top of it would be.
I was praying that it was.
Okay, so the calculation is equal to, it's also a vector. A cross product between two vectors is also a vector. The first component is the 2x2 matrix using these two columns. So if we cross multiply and subtract, we have 3. 1 times 3, 1 times 2, and subtract, so it's 1. 3 minus 2 equals 1. The second component is using the first column, column 1, column 2, column 3. The first column behind the third column. And then we cross multiply and subtract. So it's 1 minus 3, negative 2. The last component is column 1 and column 2. Made a 2x2 matrix. Determine the calculations 1 times 2 minus 1 times. Okay. So that's the vector. That's calculation of the cross product. The area of the parallelogram is because we're using these two vectors.
Me and definitely.
Outside.
Are they walking?
It's just 3. 2.
So the last thing is to find the magnitude.
Remaining.
Parallelogram made by these two vectors. The area can be calculated by magnitude of the cross product. Okay, thank you.
This is how much the drums are. I see this.
So the answer is. So if we have A and B, two vectors, hypothetically speaking, if you're drawing them exactly in 3 dimensions, it's going to take time. If you want to draw exactly, you have to draw this 3-dimensional axis system. So hypothetically speaking, if we have A and B, the area of this parallelogram. This is also A. This is also B, since they are parallel. So the area between these two pair of vectors is the magnitude of A. So magnitude of A cross B is the area. So that's what we went through yesterday. They're gonna go square root to 1 plus square root 4. And 1 plus 6, really square root of 6. So the final answer is the root of 6. Okay, let me know if you have your answer already calculated, and the basically is square root of 6. We find the cross vector, the cross product vector, and we find it's 92. So you all already submitted your answer. Hope that you have your thing. Rihanna, let me send you the link.
I'm like, I'm fine now. Because we know that second school and the students will have one. So I think you
Oh, I have no.
already knew that.
No.
No, I would usually say.
The scanner is still on. You should be able to submit now.
Is, sign, yeah. Signs.
You can see what's on my side.
Was he's.
Right, and then,
So I guess that's good.
move your cursor over to the little circle behind before A, make that choice.
You just. You just don't.
It's root of 6.
On one.
Square root of 6 is yeah, able to answer.
Like, that might actually be,
So this is the final answer. It's supposed to be A, that's square root of 6. Any question from homework?
Yes.
Question from homework. I'm handing out the test paper. I assume you all have your test paper. All right, so if you're online, I won't be able to give you the test paper, but you should be able to see your grades on Georgia View. Who's answering B? Are you still online? Okay, Fabian, I think it's your answer. You might want to switch it to A. Are you still online?
It's been for 10 hours. Like you're not showing up to class for me. I wonder how you.
You should be able to change your answer. Okay, I see.
My Wi-Fi is. Sorry.
Okay.
Maybe how that.
So one of the main thing I want to is to have some, have the test give back. And then maybe I'll have a few survey question over the test question. What do you think of the test? It was okay? All right, so I normally want to find out how are we doing as far as the test is going. So here we are. This is one of the questions I asked before. I mean,
Yes.
it's
It's a direct reflection of
the
the effort you put
reflection
in.
for test response.
It's so good. Did you put in
Okay, so. Show what is. Oh, very sorry. So overall, I have so far maybe. So far we have 14 yes and 2 no. Okay. All right, so overall, I think it was okay. I also put up the test average on Georgia View. It was like this, test for data. We do have a few students that need to make it up. The whole class has 32 students. We have 26 students who pass. So that means at least 6. That was exactly 6 students didn't take the exam. You're welcome to try to schedule by before the end of semester. I think if you want to make up any past tests, the last day for any makeup test is May 12th. V12 is when the grade has to be submitted. Any questions? So you can see the data, the highest score is 104 because I added the action pattern from the homework. The lowest number you can see, you have a few lower points on the graph. This is a plot statistics of the class data. You can see the standard deviation, see the median. Any questions? We were trying to finish 10.4 yesterday. Let me turn this on.
Field,
No.
the courtyard, garden.
They always do it. The gym. Trying to recruit. Thought that they're probably playing there to try to recruit people because the bell tower has a lot of traffic.
Well, they were doing there.
The drum line. I'm assuming that they're trying to get people to join the drum line, so that's why they're at this. There's something, I thought you said.
There was a guy I think videoing it. I'm 22 instruments. There's 1 pliers and 2 instruments.
Yeah, they're recruiting. And then
So are they recruiting drummer or dancer?
drummer. Okay.
Well, that's a good reason to dance too. Okay, so we were at 10.4. This will be the last section of new material. So we're not gonna go any further into 10. But hopefully this get us ready for chapter 10, where we're gonna focus surfaces and equations. The rest of the section, we're moving on equation of a line in space, equation of a plane in space. And then, so there's more specific topic after where we introduce the idea of vectors. So a vector is a way to study, study motion in space or surface in space. Okay. But let's just assume that's our background music. Now, where we are, volume calculation, yeah, so volume calculation is where we stopped. To calculate volume defined by 3 vectors, we would be able to find using the triple product. Let's try a question from our homework. I think I was trying to open the homework for, I made a mistake yesterday, so it should be open now.
3. I like like there's other instruments.
The homework is already open. 10.4. Well, anything that
That's wrong.
so the question 9 is an area calculation. And you know, area calculation for the parallelogram is find out 2 sides. So if you were trying to finish this question, you first want to identify vector AB. And then identify, you'll probably have to try to plot it properly to identify what was the side of a, what is the side of the parallelogram? Once you have the side vector with a common vertex, then those vectors cross product will be what we're calculating. Then we can find a question with volume calculation. So this is a volume calculation on the homework. Anything else similar to it? I guess that's the only volume question. This is the area of a triangle. So we have area triangle, area of parallelogram, volume of parallelogram. So those are the geometric question that we have in this section. So let's use this as an example. So this question says we are forming a parallelepiped using 4 points. So these are not the vectors, so P, Q, R, S, those are points. So you first have to find the vector, and when you try to form the vector of the parallelogram formation, you want to make sure you start with the same point. That's why we identify PQ, PR, PS. So those are the vector we would first calculate. So here we are. Let's try to form this one. And you can see when you are using cross product or dot product to answer the question, the number one thing is trying to make sure it is clear. Larger. Like it is clear which vector you're working on, because you might be using the wrong vector. For example, in this question, those PQRS, they are not vectors, they're just points. So we have to actually find the vector that represents, find the component that represent the vector. So the first thing we will do is identify the vector P, Q, P, R, P, S. So that's the name. All right, so let's try to get those 3 vectors ready. And then when those 3 vectors are determined, the component is clear, then we can calculate their triple product. So we start with PQ, which is equal to, we make it into a vector. The vector component is the terminal point minus the initial point. So it would be X for Q minus X for P. So it's -1, -3. I mean, minus the negative number is actually like plus the first component. Okay, and the second component for PQ is 2 minus 1, which is 3. And then the third component, 6 minus 3, which is also 3. So altogether, that's gonna be 2, 3, 3. Like that. And then we do the same. We're also gonna always start from the same point. We're gonna find PR. So that would be, what's PR? PR, -4 minus -1, -1, -2 minus -1, -1, and 2 minus 3, that's also -1. So that's the second component. You do the same for the last component, which is PS. And I hope the process is clear. S minus 3 minus -3 is 6. -3 minus 1 is -2. 5 minus 3 is. So we identify those 3 vectors. Those are the 3 vectors that the edges of the parallelepiped. So it's kind of like this. PQ. I guess I'll just draw the size. Suppose this is P. This is Q. All right. And then you might have one side as PR. And then you have one side as PS. So this looks like it doesn't look like 3-dimensional. I would just hypothetically envision what we see. And then this is gonna, so this is parallel to the PR. And then you draw another parallel line. And then this is parallel to the PS. This is a PQ again. Right, so that's what's making it slightly looking like similar to a parallel rapid. But then the graphing, of course, is not required. And what we want to do is to calculate the volume of this figure. So the volume calculation is, so we were supposed to do the triple. You would cross product first always. So there's supposed to be a little error. Since there are vectors. Okay, so it's vector PQ cross vector TR. triple product is a multiplication of three vectors, but you cannot do all dot product because you won't be able to dot between a vector and a number. You cannot do all cross because a vector crossing a vector and a vector, two vector, well, I guess it's possible to do all cross product. But we're not doing all cross product, we have a combination. So you do a cross product and then you do a dot product, dot to be PS. All right, the order can be changed, whichever combination, you're gonna find the same number anyway. You can also do PR cross PS and then dot PQ, or PQ cross PS and then dot PR. It really doesn't matter. Maybe the differences is in a positive or negative. If we switch the order, sometimes it becomes a negative number, but it's the same number. So that's why we would take a absolute value of that dot product, and that will be the volume. So this kind of indicate the process. So what we're gonna do is we will calculate the cross product first. So it's PQ cross PR. Right, so then we're gonna really are finding cross product of these two. So we can actually apply it because right now it's already in a vertical form, one on top of the other. So this is equal to, we will cross multiply and subtract. That's -3 minus -3 is actually 0. Okay, the second component, I guess we add one more row. We have 2 and 1. Cross multiply and subtract. That's 3 minus 2, which we get 5. And the last component is this first two column. So 2 times 1 minus -5. -2 minus -5 is negative. -2 minus -3. Okay, are we okay so far? The cross product, is it okay? Okay, so then the next thing is we're gonna multiply the dot product of the PS. Okay, and then what's PS? I'm gonna write it over here. Okay, remember we were supposed to do a dot product. So if we do a dot product of these two vectors, you have 6 times 1, 5 times 2, 1 times 2. So that's, is that right? It's gonna be absolute value 0 minus 10 plus 2. So it's 8, -8, absolute value is 8. Okay, I might want to double check if I made any mistake. This is according to the triple product process. But a little bit, let's see myself from making any mistakes. So PQ, that's 2. That's 3, okay? Let's try the PR. It's -1. That's also -1, so that'll look okay. PS, 3 minus 3. Kind of pair them, see. It looks okay, numerically, so PQ cross PR. They are identical, so whenever, if it's a matrix, if that's the same, so this 3 -1, 2, 1, 3 minus -2, 2, 5. -1 minus -3, 1, and then we multiply. So the final answer for the volume is 8. And try it. Are we okay? Do you have the same answer? Are we getting the same answer? So let's put it in to see if it's right. I always find myself tend to make mistakes, like miswriting or miscalculate something. Not right. See, I felt like something because I felt like it was a different number. Do you see any errors in my process? 2, 3, 3. The process there, I feel like I probably made a mistake. Don't know which one, 3 minus 3, 3 minus 1. Tend to make mistakes with the cross product. Oh, I realized which one. It was this. This first column is 2, -1. I was copying over, I made a mistake and didn't copy the negative sign. So there's negative here. Okay, so that means the second component is incorrect. So cross multiply 3 times -1 is -3. -3 minus -2. -3 minus -2 is plus, so it's -1 is wrong. Right, so we receive a -1 in here instead of 5. I have a feeling I was wrong. So that was -1 you said, and then we multiply, and then therefore this number is supposed to be a 2. So the calculation will be to remove the mistake. I'm trying to use a different color to indicate where it's wrong. This is a +2. So it's 0 plus 2 plus 2. So the final answer is 4. So the volume should be 4. Because I felt like I did this question before, same question. So the volume is 4. That was an example on the volume calculation. You can see the cross product calculation, because it's involved copying, I copied the wrong number there. That was a mistake. I didn't copy the negative sign. There's another method for this calculation. I mean, it is always beneficial to have more way to do the calculation. One of the other method will be what is being introduced on the textbook, that you lay out the 3 vector and then use the multiplication with diagonal. So the first row is 2, 3, 3. And then second row is -1, -1, -1. And this last row is 6, -2, and 2. So you can, if you have the algebra experience, all you have to do is find the determinant of this 3 by 3 matrix. But if you're not familiar with that and you don't know how to calculate the determinant of matrix, we follow what's our textbook. That is, you repeat the first column, first 2 columns. You add 2 more columns to it, and that means it's to a big table, or you can call that a matrix of 3 by 5, 3 row and 5 columns. So what we do is we cross multiply. The positive diagonal goes this way. Okay, so that will be 2 times -1 times 2, and you get -4, and 3 times -6, and you have -18. And then 3 times -1 times -2 is a +6. So that's the positive diagonal. And then we have the negative diagonal. This is 3 times -1 times 3, that's -18. Right, and these multiply across, that would be positive. I'm trying to find the determinant of the volume calculation using the textbook method. So this will be -6. But remember, this is a negative diagonal, so you add a negative. Right, so then the final calculation will be, this is -18, which is 18, and there's a -4, okay, and this is a -4, so combine them and give you a negative. Well, 4 minus 6 is -2, negative, but if you I give you a 2. So over here, we have a 2 for this. Right, for the positive diagonal, when you finish combining, and except the 18. Then we have 2 as well here. So we combine them, the total is 4, so volume equals 4. That's another way to do this calculation. And you can see, right, you set up this entire process, but it does, this is the pure calculus way to do triple product. All right, but over here is what's another method for this volume calculation. But both methods should provide the same answer. I can explain. In the textbook, we were given this method. That's why I'm copying over calculation. But you can also do the triple product thing. For example, the textbook solution, I guess we can try one more example. All right, that was a solution for question 8. All right, let's try again with the same volume calculation. All right, so basically, whenever the vector is already done, what you do is you do a cross product, and then you dot the third vector. For example, this is -1, 1, and 0. If you do the cross product, it would be the first component, it would be 0. And u cross v is 0. And second component is column, which also will be 0. And last component is 1 times -1, 1 minus -1, which is 2. Okay, so that's u cross v. And then we have w, the last time we're going to do a dot product. Dot product is multiply and add. So then the triple product is u cross v, and then dot w, which equal to, this is 0, this is 0, this is 2. So then we're going to get 2. Right, and that's the volume formed by these 3 vectors. Volume of the parallel packet is 2. And that was this calculation using the triple product in the textbook's example. The question, the answer to this question is 2. This is, of course, the 3x5 matrix method. What you do, again, you multiply diagonally. Cause of the diagonal, if you 1, 0, 0. The negative diagonal give you 0, 0, -1. But the negative diagonal is, you're going to flip it to a negative sign, that would be 1. So over here it was 1, and over here 1 plus 1 is 2. So that's the volume calculation. Any question? That kind of provide that example. The last example in this, again, is kind of like with section 10.3, the dot product. We have example over work. Work is a dot product between the force vector and the distance vector. Now, this one we were talking about another physics example where the cross product is being applied, and this is talking about when the definition is torque. Torque is a measure of the turning force applied to an object. For example, when you want to screw a nail or putting a nail, right? We turn to put the nail in, right in the wood. So when you turn, your force is being applied horizontally, but then the screw is going perpendicular, right?
Opposite.
Right.
Yeah.
So it's, I guess,
Now the screw.
yeah, I see. I was talking about school. For school, you have to apply what we call a torque.
You have easy.
Another good example of torque is there's actually a specially designed socket wrench called torque wrench.
Yeah.
Where basically adjust the setting whenever you reach a specified amount of torque, it'll make a little pop sound and tell you exactly
Let's see.
the exact torque.
Yeah, that's torque.
So that way you don't like strip the threads off of like a oil pan. Oh.
Then I don't understand. I have no experience with pens.
Your oil pan, whenever they change the oil pans, there's a little bolt on the bottom of it that they pull out to drain the oil out.
I see.
And the threads are very fine, so if you just like grip it on there, you can like rip it out and you have to replace the entire.
I've never changed oil in my life. But yeah, that makes sense. Okay, so basically this measured torque, it's being, this is a Greek letter tau. So torque equal to L cross F. F is a force vector. Again, in physics, the force, it has direction and has magnitude, so force is a vector. And then L represents a lever arm. So let's look at the picture. In this picture, so this is talking about a lever. I guess we could try to make an example. So this is a nail, and this is something that you're gonna turn so that it will pull this, will move this one in and out, right? When you turn, you try to, not a nail, I should say it should be probably a screw. Anyway, this is the example we're gonna apply. This notion, apply the cross product to solve a problem. So this question, we have a lever of 2 feet, make an angle of angle with a horizontal 45 degree. So that is giving the magnitude of the lever, which we call L. L has a magnitude of 2 and an angle of 45 degree with the horizontal axis. And then we want to find the resulting torque with a force of 10 pounds applied to the end of the lever. So that is the 10, the force equal to 10 pounds. That's the magnitude of the force, like how much the force is. So we also need to know the direction of the force. So the first example is the force is perpendicular to the lever. So that means F and L are perpendicular. In that case, we want to calculate the torque. Second question is the force is making an angle of 60 degrees with the lever. And we want to find out how much the torque is. Okay, so here is a picture showing the two scenarios. So the first one is on the left, when the angle is 90 degrees between the torque and force. So you can almost think of the center of the lever. This is where the screw is, and this is where we're pulling or turning. Hope that can make sense. So this second example on the right, the force is not perpendicular to the lever. Conceptually speaking, that would not be the best way, I think, right? We would prefer to have a 90 degree between force and torque to magnify to make the torque as big as possible. Any question? So we're going to calculate the torque. So torque would be a vector that's perpendicular to the L and F. Because it's a cross product, we're going to calculate F cross L. So this way, it's easier to move the F over here. We were supposed to do F L cross F over F cross L. With L cross F, that's how we define it. So we're gonna do this. Okay, F and then L is this way. Okay, so the torque is turning in, so that we're moving the screw in the surface rather than out of the surface. Are we okay? So let's look at how we analyze it. So basically, if we're trying to answer the question using the cross product or dot product, you want to make sure that the vector is clear. And let's try to copy over the information and then apply it to the picture. Let's do it one by one. All right, hopefully this is useful when we were solving this similar kind of question in our physics class. So that was the picture. I'm going to solve the first scenario, which is that one. Okay. So according to the question, the lever, which is L, is making a 45 degree with for the axis. So when you think about it, it would be this way, okay? So this angle is 45 degree. This length, this magnitude is 2. Right, so we can now represent L as a vector. So we write L is equal to 2, that is the magnitude, multiplied by cosine 45 degree. And then sine 45 degree, this is the unit vector. Unit vector where the angle is 45 degree horizontal. Any questions about the force? Are you okay? Okay, so 45 degree cosine is root 2 over 2, and we multiply by 2. This is really just root 2. That's also root 2. And you can see the first component and the second component of the L vector is this is positive and this is positive. So it's going left, going to the right, and then going up. So both of them are positive. So the value that we have there, it makes sense. So that's the L vector. So the question 1 explain the force. Force is equal to, we are represented with a vector. According to the given information, the magnitude equal to 10. Now we need to know the angle of the force vector. The angle is 90 degree, and this is 45. Apply a little geometry there, and if you extend the force, right, you have to draw it with a straight line this way. Okay, right, because this is 90, then this is 90. This is 90 degree. So then this is 45 degree. Because that was 45, this is 90. Now they're in the same triangle. So we can see 180 minus 45 minus 90 is 45. Why do we want to know that? Because I really want to know what was the force, what's the relation to the horizontal axis. You can see it was that 45. Okay, so it was it would be 45 degrees below the horizontal axis. So we can call that negative 45 degree. So it would be cosine negative 45. And then sine negative 45. That's the angle between the force and the horizontal axis. Since it's 90 to the lever. This. Right, we're getting ready for the calculation of the vector. So you will have 10 times 2, you can calculate. Cosine negative angle will equal to cosine positive angle, and cosine 45 is root 2 over 2. So this will just be root 2 over 2. Sine negative 45 is negative root 2 over 2. So now we have our force equation. Force is equal, the force vector is equal to 5 root 2, and then negative 5 root 2. Because we have the 5, we have 10 times 1/2, that's why we get 5. So now we're ready to do the cross product calculation. And we want to calculate the torque. It's a vector that's calculated by L cross F. All right, and what we have is root 2 and root 2 for the L, and then the force is 5 root 2 and negative 5 root 2. And then remember, we won't be able to calculate cross products if we only have 2-dimensional vectors. So then we have to make it into 3-dimensional. Add 0. Add another 0. So this cross product, we've done it before. The first component, cross multiply and subtract, is 0. This one, move it over, cross multiply and subtract is also 0. So then the cross product or the torque we end up getting is perpendicular to the xy plane. So 0, 0. And this you cross multiply and subtract is negative 5 times root 2, 5 root 2 times root 2 is 10. Negative 10 and subtract, so it's negative 20. So we have a torque that's directly going that way. That's the answer to the first question. Any questions? Because the first two component is close to 0, so the magnitude of the torque is actually 20. So sizable value, right? The second question says we want to find out if the force makes an angle of 60 degrees to the lever, what will happen? So the second question is this, and I guess we can compare. Even. So this, right, and then the visualization of it is this 60 degree to the lever. So we're turning it this way, but at an angle. So what would be is, I mean, in physics, people would tend to analyze it. So the force can decompose it into a horizontal one and a vertical one. The vertical one is one changing the direction, and the horizontal one is actually changing down the size. Anyway, so we're gonna do the same calculation. We probably have the same value for the lever. I mean, there's no change to the lever. What changes is the force is at a different angle. There's a value for the lever, and then the force is now at a different angle. Let's look at it. So this is, that was 45. If you extend it, this is 60, so this is 120. There we have it. So 180 minus 120 minus 45, which is 15. So it's 15 degrees. It won't be easy to do the calculations. That was 15 degrees. And I mean, this is 15 degrees. So the force is now equal to, so then the magnitude is still 10, but then those change. So those are going to be cosine negative 15 degrees. So force is equal to 10 times cosine negative 15 degrees. Then sine negative 15 degrees. Any question? All right, and then we're gonna calculate from there. And we know the final answer is gonna be a cross multiplication, cross product. So let's slide them up for computation. So then L, the torque is equal to L cross F vector. So equal to, what do we have? We have 2, and that's cosine 45 degree, and then sine 45 degree. And then there's a 10 cosine negative 15 degree, and then sine negative 15 degree. Okay, we were supposed to add a 0 and get ready for the cross product calculation. Let's multiply. The 2 times 10 is a common factor. You multiply them, that would just scalar, so we get 20. All right, and then in the calculation, this is 0, and then we are making this into a vector, so you dimensional vector, and then you're gonna cross multiply, right? So 0, 0, kind of like what will happen here. The first two components are 0. The last component is a non-zero one. So the non-zero one is going to be cosine 45 degree, and then sine negative 15 degree, and then minus cosine negative 15 degree. Yeah, minus negative cosine negative 15 degree, and then sine 45 degree. Right, so, I leave this part there because they fit into a, subtraction angle calculation, right? Okay, so when you have cosine A, sine B minus sine A, minus cosine B sine A, so that is a subtraction angle calculation. So this is actually equal to a little bit additional formula. So 0, 0, then we have sine. I think it's sine negative 60 degree. So then this is A, this is B, you subtract them because there was a subtraction sign. Cross multiply, subtract. So sine negative 60 is actually negative 3/2. Okay, so it's slightly smaller than before. The first example, the work is 0, 0, negative 20. Now this is going to be 0, 0, you get 20 times negative 3, so it's negative 10, 3. Just slightly lower than 20, right? That was the final answer. I think I may have made it actually complicated by quoting this formula. But you can not rely on the formula, you can just go ahead and use your calculator. So cosine 3 times sine negative 15 degree minus cosine negative 15 degree times sine 45 degree. So we can pretty much calculate the decimal value, but make sure your calculator is integratable. I felt like that's combined, that can be combined together. That's why I wanted to explain if you can find the subtraction angle formula. Textbook already provided the solution for the first scenario. The lever is √2 vector. The force is 0. The force is 5√2 and negative 5√2. So when you cross multiply, you have to add a 0 in order to run the cross product calculation. So we have this is a torque. The magnitude is 20 for this torque vector. The second scenario, we have a cosine 15 degree, cosine negative 15 degree, and sine negative 15 degree. In that case, most people don't remember the root formula for cosine 15 and sine 15. So instead, I kept it as a cosine 15 as a part of the notation. And then you do the cross multiply, you can see the last component is negative 10√3. I use the additional angle formula, subtraction angle formula instead of the root formula. But ultimately, the final answer, if you calculate it using your calculator, this is negative 17.321. So the torque have a slightly smaller magnitude if the angle is not at 90 degrees. And that's the reason why when we turn a screw or work on things like circular motion, when you push something, right? When we, when we push the lever of a mill, right? Is miller the word? The mill, right? Right, we turn, anyway. So when we were using circular motion as a way to force things to be crushed or combined, and this is the situation, the angle you always try to do is keep it at a 90-degree angle with the lever. Right, this is a example that kind of illustrated where one of the situations when the cross product is being applied in minutes. Let's see. The rest of the question in the homework, try number 8. Most of them are practice the cross product calculation. I hope that you were able to try, and we tried question 1 yesterday. And let's see, this is also a cross product calculations example. Right, so first lecture is -3, 3, -1. Second lecture is -3, 3, and 1. Find cross product. This is calculating area of the triangle. You want to find the vector. We can keep the 0, 0 as the initial vector. So the first vector will be -0, right? The first vector will be -3, 3, 1. The second vector will be -3, 1, -2. And then we find cross product, the area of a triangle should be the one half of the area of the parallelogram. And the area of the parallelogram is magnitude of the cross product. Find the cross product and then find magnitude and then divide it by 2. Any question? And question 4 is to determine whether the point lies on the straight line. So how do we know if the point lies on the straight line? These are 3 points, right? When 3 points are on the same line, they're not going to form a triangle. If they're on the same line, when you connect them, they're on the same line, so you can't form a triangle. So the area of a triangle or area of the parallelogram will be 0. That means the cross product equal to 0. So one of the ways people do, which would be find 2 vectors, such as the first one, you find A, B, A, C. If the cross product equal to 0 or the cross product equal to 0, 0, 0, then we know it's all on the line. If the cross product is not 0 in a magnitude, then they are not on the same line. So cross product could be a way to determine whether the vector are along the same line. And you can count the first one, 8 minus 0. So it's 8, negative 1, 3 is the first vector. Negative 32 minus 0, they're all minus 0. So the second vector is negative 32 or negative 12. And we can see if these two are parallel, 8 times 4, 1 and 4. So the ratio is negative 1 to 4. So we multiply 8 by negative 4, we get negative 32. Negative 1 times negative 4 is 4. 3 times negative 4 is 12. So they're parallel, right? So that means AB and AC is parallel. If they're parallel, then their magnitude, their cross product equal to 0. So the first one, they are lying on the same line. Yes. The first one is easier because we have 0, 0 vector in there. The second one and the third one, the process will be, again, you have to find the vector. The points are not the same as vector. So for example, I'm going to work out the question number 2, and then I'll leave you to do number 3. So for the second one, you have to find where the vector is. So we would find vector BE, which equal to 1, 2, and then 6 minus 3, 1, 2, 3 instead. Okay, and then we also then find DF, and we want to see if they're proportional. And that's 5, 9, that was 10, 18 minus 3, that was 15. Okay, so the ratio is 5, 10, 15, 1, 2, 3. Same ratio, right? Are we okay? So times 5, you get, so then we can see obviously that DE is parallel to DF. I'm using two vertical line between 2 vectors to indicate they're parallel. Because they're parallel and they're going to the same point, so they're along the same line. Also, you can tell that DE cross DF is a 0, 0 vector. Try to find the cross product, it will be 0. So we would say, yes, they're on the same line. And I'll leave you to do the third question, but that's 1 or 2/3 of this question. So this is how we answer question about how to determine whether points are on the same line. Number 5 is, if we put it this, whether these are perpendicular, parallel, or neither. Okay, so if they are parallel, like the first one, 4 to 8 is times 2 and then times negative. So the ratio is -2. -3 times -2 is 6. 2 times negative. So is -2 being the common ratio among all the components? Proportional. So this one is parallel relation. Now the second one, definitely not parallel because -4 to -16, the ratio is 4, but then 3 to 6, the ratio is no longer 4. So this one is, it's not parallel, but are they perpendicular? to be perpendicular, the dot product equal to 0. So this time that's 64 minus 18. And then what's that? That's negative 46. 64 minus 46 minus 18. Okay, so about whether they are perpendicular, we will have to do some calculation. Right, so that second pair, this and this, they're not parallel. You see the proportion is not right. But we're gonna calculate the dot product in order to determine if they are perpendicular. Perpendicular to the dot product of 0. So it's 64 is the first pair multiplied minus 18, and then minus 46. Let's say if they are equal to 0. It is equal to 0. So it's perpendicular. And then the third one, you can see it's not proportional because we have 4 to 3, and then 3 to 1, and 2 to 3. The ratio is not the same, so they are not parallel. And then let's do the dot product. 4, 3, negative 12, and then negative 3, and then negative, they're all negative. So if the dot product have multiplication now equal to negative, so the dot product is not 0. So this one, the answer will be neither. The last question, definitely not parallel, but whether they are perpendicular, to do the calculation. So let's say this one has more numbers, so the calculation is not very clear. To determine if the vector are perpendicular, we need to calculate their dot product. So dot product will be negative 4 times negative 17. That's 4 times 17. Which is 68. So we have 68 minus 3 times 18, and then minus 14. Is that 0? What's 3 times 18? 54. So it is 0. So then, because the dot product equals 0, and this is perpendicular, so that's the answer for question 5. I hope that's clear. Any question? Well, lately, the ballot is more clear. So let's see, this question have a couple of conceptual questions. The first question says, for any scalar, which is just a number, and any vector, the magnitude of CV equal to C times the magnitude of V. There's a little problem if C is a number, if C is negative, all right? The magnitude of any vector is positive, but C there might be negative. So for A, for the first question, we worry C might be a negative number, and that will be equal on the left and right. So we would say it is false. Second question says the value of V dot V cross W is 0. I mean, the second one, true or false? Second statement, true or false? That's dot product, right? A dot product will equal to 0 if they're perpendicular. So are they perpendicular? V and V cross W, is it perpendicular? Do you remember? V cross W is perpendicular to V and also perpendicular to W, right? Remember? Cross product has, by definition, it has this idea of perpendicular relation. So this is supposed to be true. All right, the third one, true or false? Yes, it's true. That's the triple product as long as the order is there. So the order would be on the left, order is IJK, on the right is IJK. Yes, that's true. Unless you switch one, the IKJ, then it's IJK, then it's, if you switch the order, then you have to switch the signs. You have to add a negative sign to it. But right now, I think that was true. Number 4, true or false? So the length of V plus the length of W equal to the length is the magnitude of V plus W. Are they,
Say true.
they're not. The magnitude of vector is actually the length of the vector for vector. Right. Like this. So basically, let's say V. Let's see, this is V. This is W. So what's V plus W? Now, this V will be the length. This magnitude of V is like how long this one is. Now, the magnitude W is how long that one is. So the magnitude is the length of the vector. Now, what about the V plus W? According to what we're talking about, you form a parallelogram. That one is the color. So V plus W is this. And you can see the length. We can actually put it into a triangle using the triangle rule. Head to toe, this is the V. So I'm drawing is actually W plus V. This is W plus V on the side, and then are they the same? It's not, right? The length of W plus the length of V actually is bigger than the length of the diagonal of the parallelogram, right? Right? They're not always equal. When are they equal? It's when they are along the same direction, it's when they are parallel. So if they are the same, for example, if you go V this way, and if the W is the same direction, this is W, right? In that case, this is the V plus W. Then they will have the same length. But right now, it's like this is a straight line, but then you turn a little and turn a little. The driving distance is going to be definitely longer. This is a summation part, this pass. But this one is going straight, which definitely has a shorter distance, therefore shorter magnitude. Are we okay?
Yeah.
So it's related to the angle. If they're not along the same angle, then they won't be equal. So that's not true. It's true for this kind of special situation. We'll answer false on that one. I'm not sure if we're getting the same question for number 6, but sometimes the selection, the question bank are different from student to student. This is our question 6, a conceptual question. Number 7. It gives us the dot product and the magnitude of the cross product. And the question will be, what's the angle? What's the tangent of the angle and what was the angle? Sometimes I have students that was really confused about this question. So maybe I should try to explain this example before the class is done. So then you can kind of remember review the formula involved, the dot product. With 10.3, we have the relation, a dot product actually equal to the magnitude of V multiply the magnitude of W and then multiply cosine of the theta. So that's the dot product relation provide. And then what about the cross product? Magnitude of the cross product. V cross W. V cross W is a vector, but magnitude of V cross W is a number. This number, according to Tim Points, equal to magnitude of V, magnitude of both, magnitude of W. And then you're going to multiply. Do you remember what's the last thing? What's the last thing? You remember the formula? Magnitude of V cross W equal to sine theta, yes. So we multiply sin theta. Alright, so these are two different formula, one from 10 point, the 10 point is from 10.4, the dot product formula is from 10.3. And right now we're saying that this is equal to 4. This is equal to 2. So basically question is giving us information for both. Okay, and we don't know theta, but we know this now. We know this, okay? Because the relation, so you put in the formula, since that one equal to 2, this one equal to 4, now we can divide, right? Equation 1, divide equation 2, which cancels the one we don't know. We don't know the magnitude of any of those vectors. But if we are looking at this equation, that equation we divided, you take equation 1 divided by equation 2. You will cancel the common factors. Those are going to be common factors that was canceled. So we would end up getting tangent theta, means sin theta divided by cosine theta is tangent theta. So tangent theta equal to 2/4, is what it says. And 2/4 is actually equal to 1/2. So that's 1. So that with that we would say this is actually equal to 1/2. All we have to do is take this number divided by that number. And that gives us the tangent theta. All right, so now that we have tangent theta, how do we find out theta?
Arctan theta.
Arctan, right. So what we're gonna do is to just go tangent inverse of 1/2. That's the angle, yeah. So when we have the tangent value to find angle, we would just tangent inverse. There's many angles that have the tangent, but at least tangent inverse give us 1. If you want to find the rest of them, you add a pi. But we're just finding the angle. The angle could be acute or obtuse. Right now, the dot product equal to 4. Being positive, means the angle is less than 90 degrees. So we're looking for angle in the first quadrant anyway. So tangent inverse should be enough. Any question? All right, just in case if your dot product equal to negative, if this is a negative, and you have to take the tangent inverse calculation, you have to plus pi. Because if the dot product equal to negative, we will have the tangent inverse give you a negative angle, but the angle we're looking for has to be between 0 and 90. That's why we have to add it. But this example we have a positive dot, so that we don't have to worry. Any question? That I'm hoping that by providing more example, more people are able to finish this. Now the last question is area parallelogram. Remember to find the vector first. I might want to try the graphing, and maybe that'll help if you graph this a little bit. We would draw them, right? 2. And then 2, so that's A. B is at A3, 1, 4, 6, 8, and then 3, 8, 3. C is at 4, 8, 4, 8, 1. D is at 10 and 9. Okay, so it's kind of like this. So that's A, B, C, D. It's like this, I think. Okay, so I'm trying to visualize how it looks like. You have to find two sides of it. Like, is it AB or AC, or is it CD, or is it AB? So you want to draw, like visualize the parallelogram before you're determining. One way to do this is you can see the CD vector is 10 minus 4, 9 minus 8. So that's basically 6, 1. And the vector AB is 6, 1 as well. So that gives you the idea that AB is parallel to CD after you determine the vector. Right? Are we okay? So you can find the component for AB, 6, 1, component for CD, also 6-1. So we know they're parallel, so the shape is fine. And then so to calculate the area, you have to identify, I don't have time to finish, but you have to find out AC vector from A and C. Start from the same point. If I start from A, so I find AC, then I find AB. AC and AB is from the same vertex. So that AB and AC become two sides of the parallelogram. The area of the parallelogram will be cross product of AC and AB and then magnitude. The magnitude of the cross product between these two vectors will be the area of the parallelogram. And that will be it for today. I hope that kind of explains how to finish with our last lecture. And I'll see you tomorrow. We'll probably talk about the final exam tomorrow. Yeah, if you haven't, yeah, you can yet let me know. On the other hand, if you haven't, like, if you're loading your solution question, then log one. There, do you want to, exam? Anyone not having your exam back? Any?
Thank you.
Oh, did you answer this one? You already answered, yeah?
Yeah.
I'm gonna make sure I recorded it. You didn't take the exam, I see. You don't wanna take it? Okay. Okay, you can study more on how to schedule a makeup. I can still allow makeup test before the semester is over. So what about next week? The last day to do any exams is May 12th. Our final exam runs to May 6th to May 12th, and then we have to submit the grades. You should try to do more homework. I mean, the question on the tests are,
Exactly.
yeah, some of them are exactly the same. Some of them are variation, but the homework really provide practice question that allows you to understand. I reopened all the homework, so if it's possible, try to finish the more homework, the better. And each test, like our test 1 is chapter 5 and 6. Test 2 is all the chapter 7, and test 2 is 7, and test 3 is all chapter 8. So if you want to make up one test, you want to make sure that chapter is done, at least the homework is done. That way you will kind of see how it works.
So one bit. And I haven't been getting the workshop.
Yeah, you want to try to gradually finish more and more homework. Once your homework is done, then you're ready. You're trying to catch up the homework and see if you're able to practice. There's practice question on tutorial. So you can follow it.
I know something like if you ever work on time,
You get extra credit for the work that you done.
Oh, no, it was like you could log in as like a student. and
Uh-huh.
get, like,
But you're still, your own account still works. Yeah, student also.
I
Student,
tried doing this thing, but it didn't.
but you have your own accounts. You have the WebWork accounts, do not?
Yeah, I do, but it was like on one of the homeworks, I didn't realize that there was like.
Oh,
a
yeah.
limit to the, how
I
much time.
see, I see. You can do the student
Okay,
for practice.
I tried that, but it didn't let me log in. It said like,
They should work. Maybe you would capitalize for some reason. So if you try to log in using that, it's student and student.
yeah, that's what it would tell me.
Oh, that's because your computer has memory. It remembered the last time that you log, let me log out. I'm going to turn off the recording. Bye guys, today's class is